example 3. Suppose you have a vector u and another vector v, and they are 60 degrees. And let's say u has the magnitude of 3 and v has the magnitude of 5. Number 1, find u dot v. Number 2, find the magnitude of the projection of u onto v. And then number 3, find perpendicular projections. Let's think about this. And then number 4, suppose W is a vector that's perpendicular to V. Compute V dot 2u plus 3w. Let's think about this question. All right, first, how do you do u dot v?
Times v cosine 60.
See, if these were given in coordinate form, we will just simply write down the coordinates and do pairwise multiplication and add. But here, these are not given in coordinate form. Therefore, the only choice we have is to go back to the original formula, which said that you have to multiply the magnitudes and then multiply the cosine of the angle between. That's 3 times 5 times cosine 60 is?
Square root 3 over 2.
Nope.
1/2.
1 over 2. It's 15 over 2. So that's number. Okay. Then what about the projection of u onto v? What's the magnitude of the projection? Well, you can do this by 2 ways. One, you can use the formula which says I need to take the norm of absolute value of u dot v divided by the norm of v. And because I already know that the dot product is 15 over 2 and the norm of v is 5, 15 divided by 5 is 3, so I have 3 over 2. So that will be how you get it just by using the formula. Or you can just find this geometrically. How? You're trying to find this length, right? So, alternatively, it's the length of u times cosine theta. Because you want to project this onto here, and you just need to multiply the length of u times the cosine of theta, which is u is 3, cosine 60 is 1/2, so it's 3 over 2. So that will be how you solve it geometrically, not having to use the formula. Number 3. How would you find this length then?
Sine theta.
It will be sine theta, right? So you can just say it's, which is 3, and this theta is 60 degrees. What's sine 60 degrees?
Square root of 3 over 2.
Yes. So you can get the answer without having to use the formula. Or still another way will be you just use the formula, which is square root of u squared minus u dot v over v squared. Alright, so what's that? That's this is 3 squared. And we have this value 3 over 2 here, right? 3 over 2 squared. So that gives us 9 minus 9 over 4. And that's 36 minus 9, that's 27 over 4 square root 2. And if you pull the 9 outside as 3, then 3 is left inside, and square root of 4 is 2, so you get the same answer. But with more calculation. So formula isn't everything. If you understand what it means, you can get the answer in a much easier way. Okay. Now the fourth one. How would you do this? Any ideas? You distribute, right? You multiply these out. So you v dot 2u plus v dot 3w. And you can pull the 2 out, and you just have to do v dot u. And 3 times v dot w. Okay, what's the first one? What's v dot u? 15 over 2. We have it here, right here. U dot v and v dot u are the same because dot product is commutative, right? So this gives you twice of 15 over 2, so 2 and 2 cancels. How about v dot w? What's that? 0, because these are perpendicular. So the answer is 15. This question is about knowing how to apply all the properties of the dot product. If you didn't know that perpendicular means 0, if you didn't know that you can distribute, if you didn't know that you can commute, then it will be hard to solve this question. So knowing the properties of the dot product is important.